Hello, welcome to Maths with EJD. In this video, I'll be showing you the Python code for Primal-Dual solutions of a resource allocation problem, the same problem that was solved in the previous video manually, and it took a whole lot of time. Again, the problem statement is as displayed. You want a workshop that produces tables and chairs constrained by available labor and wood resources. The objective is to maximize profits by producing these items while adhering to the following constraints: profit per table, $20, profit per chair, $15, labor availability, 100 hours, wood availability, 80 units. Each table requires 4 hours of labor, 2 units of wood. Each chair requires 3 hours of labor and 4 units of wood, and we aim to maximize the profit by determining the optimal number of tables and chairs to produce. Okay, so you can see the primal problem directly translated from the problem statement, right? We want to maximize Z equals 20 tables plus, 20 times number of tables plus 15 times number of chairs, subject to 4t plus 3c less than or equal to 100 being the labor constraint, and 2t plus 4c less than or equal to 80 being the wood constraint. And of course, the number of tables and chairs would be greater than or equal to 0 because you cannot have a negative number of chairs or tables. Then the dual problem, of course, is derived from the primal. And now it's going to be a minimization problem where we minimize W equals 100 lambda I plus 80 lambda 2 subject to 4 lambda 1 plus 2 lambda 2 less than or equal to 20. And that's the constraint for profit for each table. And the second one, 3 lambda 1 plus 4 lambda 2 greater than or equal to 15, which is profit of each chair. And of course, lambda 1 and lambda 2 are also non-negative, so they are greater than or equal to 0. So if you come to the code now, we have just about 69 lines of code. So we want to solve the primal problem where you have 4324 as for the constraint, 4324, and then you have minus 20, minus 15 for the objective function. Then, of course, the 880, the right-hand side, and the non-negativity. So the actual solving is happening in line 20. Okay, then that will return the primary results. We also do the same for the dual. Now we have 180 as our dual, as the objective function now. But then you now negate the values of the constraints for the minimization problem. So you see, for maximization, we negate the values for the objective function while we leave the constraints the way they are. But for minimization problem, we leave the objective function the way it is and negate the constraint coefficients as we see in lines 30 and 31. Okay. And then of course we have we also negate the right hand side 20 and 15. So like that. And once all of that is done, the dual result is returned, and then we just we solve the primal and dual and everything, and we just click on this in one blow, we get our result. And just like what we got manually, right? Um, just like what we got manually, you can see we now have our primal problem solution, just like what we got manually. We had 25 tables and 0 chairs, leading to maximum profit of 500. And then we have the dual problem solution, which is dual variable U, and that's labor constraint is now 5. So it means that for 1 unit of labor that you add, you are going to add $5 to the total profit. And then for the dual variable now, you have it's 0. So, and that is wood. So just like what we saw in the previous place, that wood is not a limiting resource. It's not as important as labor. And of course, we have the minimum value for the dual objective, which is 500 as expected. As expected. So, I mean, in just less than 10 minutes, I have run through the code, whereas we spent 1 hour solving it manually. So that's why if you are dealing with something more large scale, coding works far better. But of course, I think it's also pays to know what is actually driving the code you're writing. That's why the manual thing is also important. You want to know the principle behind what exactly you're doing. So if you have not subscribed to this channel, be sure to do that right away. All right. And of course, hit the notification bell so you can always get alerted each time a new video is released. And don't forget to comment. Let me know if you want me to solve a problem or teach a topic Then like and share so that more people can have access to all of this great learning. Till I come your way again, keep optimizing. Bye.